Jacobian factors. Jacobian factors. A brief overview of Jacobian factor is, let's say you have some sort of shape. I shouldn't do that one. Some sort of shape, and it's on some plane. You see how the shape is very hard to define. Like, there's like a lot of bumps, like skipping areas. So basically, what Jacobian factor does is it makes this a weird shape into a not perfect, but something more understandable. Something in this region, sort of. But, sorry, this disappeared. This region, sort of. But to convert this, there has to be some sort of factor, scalar factor. So let's go back to my question. My question is this: what is the Jacobian factor? If I want what I need. Already off the bat, we already know this is an ellipse. So let's fix this. How do I wanna make this into a circle? So first thing that comes to mind is, let's make this into a circle. So to make this into a circle, let's think of a variable that you want. Think of any variable you want. I will choose s. And I'm going to say s is equal to x over 10. And I'm going to rephrase this into, not rephrase, but move it around. So x is equal to 10s. And let's do t from my other variable. What do you think t is equal to? T is equal to y over 17. So moving things around, y equals 10t. Let's store this. Now that we have this, let's go back. Let's make our new circle now. Given this, let's draw a circle now. Okay. Now, we still want this region. Region hasn't changed. But now it's a circle. Now it's something we can do way more of. So let's go back. Here was x over 10 squared. Our x over 10 is s. So s squared. Plus, here was a y over 17. That's t squared. And that equals 5. Here I meant to say s squared plus t squared. Please forgive me. Now here, our points are here. Y equals negative 2x. What does our y equal? Y is our 10t equals negative 2, and our x is 10s. 10s. Here, 10t equals 3 10s. Oh, that cut out. 10s. So now that we have this, no, that's actually incorrect. I am so sorry. This is 17. 17th. 17. Sorry if I threw you off. Anyway, this should be 17th. So now that we have this, let's do one more thing. I don't like having that number next to t, so I'm just gonna move that 17 across on both sides. So I'm just gonna label it top It's going to be t equals negative 20 over 17 s. Bottom 30 over 17 s. That's t equals. Now, let's make sure we have a Jacobian. Now, this is what Jacobian is. You take the determinant of old versus new. And when I say that, I mean we're going to take the determinant as x and y being our old. And you're taking the derivative of those with respect to new. So it's nope, that's not s, t, s, and t. So what does it equal? Let's see. My x with respect to s was 10. My x with respect to t was 0, because there's no t value there. My y with respect to s is 0. My y with respect to t would be 17. And then you cross multiply. So multiply this, and then subtract. So 170 minus 0 equals 170. This is my Jacobian factor for this step. This is this step. We'll also be taking another Jacobian factor because this isn't in polar form yet. But now let's move it across. So our original thing was dx dy of x. Let's get in my terms now. This is in the region R. My terms. Okay. Let's start off with the easy one. My radiuses will stay the same. So smallest radius is square root of 5. Biggest radius square root of 11. The B. Now, actually, I'm going to leave this out, because only for right now, just to avoid confusion. Then my angles, or what is it, restrictions are from, because now I have it in terms of t. I like having it in terms of t. It goes from negative 20 over 17s to 30 over 17s. And the reason why it's like this is because you're always going from least to greatest. So I'm going to draw a little circle right here. You're going to start from here, and you're going to go this way. So when I start from here, my first contact is right here. That is my first contact. So that's why we're starting with that number and going to that number. Now let's go dB, nope, not dB, ds dt. Jacobian is 170. And then recall how x is our thing in there. So we're going to replace x with what we have over here, 10s. Perfect. That is perfect. Now that we have this is our first step. Now, let's take this, because this we're only one step away. We have to convert it to polar. From there into polar. So let's do this. What did we call our s? Our s is in respect to x. So when I say respect to x, I just mean it's in the same line as x. So let's call s equals our cos theta. Let's call our t now equals our sine theta. Okay. And I think it's really important to remember parapolar rule, a squared plus b squared equals r squared. And here my a squared is s, my a is s, and my b is t. Because I'm going to actually show my work right here. s squared plus t squared. This is actually, you square everything, so r squared cos squared theta plus r squared sine squared theta. Pull the r squareds out, that's cos squared theta plus r sine theta squared. This is 1, so r squared times 1 is just r squared. So, right here. That's just so now let's go to our circle again. Draw our new circle. Let's do this. Okay. Now that this is our new circle, recall here in this circle, I have s squared plus t squared equals 5, and then my a plus a squared plus b squared is actually s squared plus t squared. So I'm just going to say my new things for that is r squared equals square root 5, that's square 5, and r squared equals 11. So from there, my r squared equals 5 and r squared equals 11. So now that I have that, that's really nice. I'm actually going to move this a little bit further away. Let's call this as our factors. Let's leave that here. R squared equals 5. Now if you recall, I had it as t. My top is t equals negative 20 over 17s. So let's do that. My t is r sine equals negative 20 over 17 r cos theta. My r's will cross out when I divide, and when I divide by cosine, that will become tan. So this is tan theta equals negative 20 over 17. I think I should erase this now. And then I want the arctan of this. So arctan of negative 20 over 17 equals theta. So this is going to be right here. And based off what I did from there, I think it's safe to say that I can just write arctan of 30 over 17. Okay, that's good. Now just one thing. I'm going to draw a circle again. A lot of circles. So arctan falls between this region, between here. So that's one thing to remember. And negative 20 over 17 is actually over here, somewhere over here in this fourth quadrant. I need it in the second quadrant. So what I'm going to do, I'm just going to arctan negative 20 over 17 is a negative number. Plus 180, or in this case, pi. Pi plus some negative number would be exactly where this arctan of negative 20 over 17 is. It'd be exactly right here. Here, arctan 30 over 17 is actually somewhere over here. But we want a third quadrant. So pi plus this arctan, this number, positive number, would put it exactly where I need to, right here. So I'm going to remember it. I'm just going to add a pi to everything right here. But this, you have to make sure you understand where I'm getting this pi from. You have to know where and how many pi's you need to add to get the angle you need to make sure it follows the rules of arctan. So hopefully you get that. Okay, now they have that. We have to get the Jacobian. So like I said, you take the determinant of old versus new. So ds d theta is negative r sine theta. ds dr is cosine theta. dt d theta is r cosine theta. And dt dr is sine theta. I'm actually going to show my work right now because it is a bit hard to understand. So negative r sine theta times sine theta minus r cos theta dot cos theta. So these combine. So negative r sine squared theta minus r cos squared theta. Pull the negative r out. Oh, I'm sorry. There's actually an absolute value right here. On all determinants, really, but you don't really need to show it on most of them. But negative r sine squared theta plus cos squared theta. This is 1, so negative r times 1 equals negative r. Absolute value equals r. So this is our Jacobian. R is our Jacobian, just r. So I'm going to bring this back. My previous thing was from... Let's get our new from personal Jacobian into polar Jacobian. So let's do it. Our radius is not changed. It's still from square root of 5 to square root of 11 dr. Our thetas, or our regions, is now, remember how I said we have to add pi. And it starts from the top, from counterclockwise. So arctan, negative 20 over 17 plus pi, arctan 30 over 17 plus pi d theta. Now we still have to use our 170. That's our old Jacobian. 10 s. What do they call s? S is r cosine theta. R cos theta. And our new Jacobian, which is r. This is it. This is our conversion. Hopefully that made sense. If you have any questions, please leave them in the comments below. Thank you.